going to see how to find distance between 2 points. Then we are going to see midpoint formula. Then we are going to see how to find the slope of a line. Then we'll see parallel and perpendicular lines and how to and the relationship between their slopes. Okay, and then we are going to find discuss equation of a straight line. Then we are going to see parabola, then equation of a circle, and we are going to see some examples for plotting graph. Raviji, is it audible now? Is the sound is clear? Are you able to hear? Can't hear you properly. Santosh, we can expect around 2 questions from this topic. Is the sound clear now? Hello? Is it clear now? Okay. So shall I start with the topic? Okay. So this is introduction to coordinate geometry. So first we shall see what is coordinate geometry. So coordinate geometry is a system of geometry where the position of points on the plane is described using a pair of numbers. So if we look at the diagram here, there is a point A. It is given as 3, 5. So it is denoted with a pair of numbers. So when we say it 3, 5, it denotes that the x coordinate of the point A is 3 and the y coordinate of the point A is 5. That is, that point is making 3 units from the origin or from the center of the graph along the x-axis and 5 units along the y-axis from the center of the graph. Okay, so the origin is the center of the graph where the x-axis and the y-axis are intersecting one another. So it is denoted as 0, 0 because both in x-axis and y-axis it is only making 0 units. So whatever point we are denoting or line we are denoting with respect to the origin, which is denoted as 0, 0. Okay, so here we have 4 quadrants. In quadrant 1, x-axis is positive, y is positive. Whereas in quadrant 2, x-axis is negative, x coordinate is negative and y coordinate is positive. In the quadrant 3, the point C is denoted x is negative and y is also negative. Whereas in quadrant 4, x is positive and y is negative. So when the points were given, just try to visualize in which quadrant it is available. It would be helpful to solve some of the problems. Okay, so you're clear with this? Shall we move with Sebin, are you able to hear properly now? Sebin? Venkat, I'm just starting with the seminar right now. So I've just gone through the first part, Introduction to Coordinate Geometry. So you can go through the slide and I'll be continuing with the seminar. Okay, so are we clear with this? How to denote points with a pair of numbers? we can expect around 2 questions from this topic, Shamila. Okay. Shall I move on to the next slide then? Next topic? Okay. So next let us see how to find distance between 2 points. Okay. So here in this graph we have 2 points A and B. So A is denoted by x1 comma y1 and B is denoted by x2 comma y2. So this is the formula for finding the distance between 2 points A and B with coordinates x1 comma y1 and x2 comma y2. That is, distance D is equal to root over x2 minus x1 the whole square plus y2 minus y1 the whole square. So please note this formula. This is important. I'll let you know how this formula came for your understanding. See the graph below. Okay, from the point B, first join the 2 points A and B. So that would be the distance between A and B. Then, sorry, I'll just point the mouse now, Adi. So there are 2 points A and B. Let us join those 2 points AB. Okay. Now draw a perpendicular from point B to the x-axis. Okay. Then from A, draw another perpendicular to the first perpendicular I mentioned. So it would meet this perpendicular at C. Okay. So now you have ABC as a right angle triangle. So by Pythagorean theorem, what happens is square of 2 of the sides is equal to the square of the hypotenuse. So we have distance square is equal to x2 minus x1 the whole square plus y2 minus y1 the whole square. So distance D is equal to square root of distance square, which is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So this is only for your understanding. So I hope you have all noted down the formula. Shall I move on to the next topic? Everyone clear with this? Okay, very good. I see a lot of yes. So let's go to the next topic. Midpoint formula. Okay, so here let us see 2 points. Okay, one is denoted by x1 comma y1. The other is denoted by x2 comma y2. So we are to find the midpoint in the line segment joining these 2 points. Okay, so that is given by x coordinate is given by x1 plus x2 by 2 and y coordinate of the midpoint is given by y1 plus y2 by 2. So just note down this formula. It's alright, Venkatesh, if you're late. We have only gone through 2 slides. Just hear to the rest of the session and you can always go through it later on. So everyone noted down the formula for midpoint of the line segment? Okay, good. So we'll move on to the next topic. Before that, we'll be seeing through questions. 2 questions on this topic. Okay? Okay. So the first question, the distance between the points M0 and 0M is the same as the distance between 1, 2 and minus 1, 3. So if M were greater than 0, find the value of M. Okay. So when the question is given, first see what all data is given. So what is given here is they have given a set of points M, 0 and 0, M. And they have given another set of points 1, 2 and minus 1, 3. Another information that is given is distance between these 2 points is same as distance between the first set of points. Okay. So what do we have to find here is the value of M, and it is given that M is greater than 0. Okay. So what formula can we apply here of what we saw? What formula we can apply here? You can think it over. So that is the the formula we use to find the distance. Yes, Jahnavi, that is distance formula. But please check your answer. No, Jahnavi, the answer is wrong. Please check your answer. Anybody else got the answer? No, Ankita, it's wrong. Prashant, you're right. Garima, you're right. Shamla, right. Venkatesh, correct. Shrikant, correct. Vamsi, you have to check your answer. Varun, you made a mistake, I think, in the last step. Please check again. Dinesh, right. Neeraja, correct. Girivasan, correct. Sebin, please check the answer. Yes, Muthukumar, you're right. So shall we see the explanation for the question? No, Nikhil, that's wrong. No, Nikhil, that's right, sorry. Arun, that's wrong. Satya, please concentrate on what is asked in the question. Okay, let's see the explanation. So the distance between m0 and 0m is d is equal to root over x2 minus x1 the whole square plus y2 minus y1 the whole square. So x2 is substituted by m, x1 is substituted by, x2 is substituted by 0 and x1 is substituted by m. y2 is substituted by m and y1 is substituted by 0. So you have minus m the whole square plus m square, which is m square plus m square. So that is equal to root over 2m square. So that is m root 2. So we have found the distance between the first set of points. Now we have to find the distance between the second set of points 1, 2 and minus 1, 3. So we are taking x1, y1 as 1, 2, x2, y2 as minus 1, 3, and we have substituted that in the formula. So you will get root over minus 1 the whole square plus 3 minus 2 the whole square. So that is minus 2 the whole square plus 1 square. So that's 4 plus 1, so root 5. So here distance is equal to root 5. Now we have to equate both. Root 5 is equal to m root 2. So m is root 5 by root 2, that is equal to 1.58. Is that clear? Shall I move on to the next question? Okay. Let's see the second question. M is the midpoint of the line joining the point P to the point Q 1, minus 3. If the coordinates of M are minus 1, 1, find the coordinates of the point P. Okay. So here what is given in the question is M is midpoint of a line PQ. Okay, the line joining P to Q. So of the line PQ, M is the midpoint. And coordinates of the midpoint is given minus 1, 1, and coordinates of the point, another point Q is given 1, minus 3. So what we have to find is the coordinates of the point P. Okay, so what formula can be applied here? Kapil, Prashant, correct answer? Yeah, Jahnavi, we have to use midpoint formula here. Yes, Ankita, your answer is right. Yes, Vijay, Nikhil, Muthukumar, Jahnavi, Arpit, Suvradeep. Yes, it's right. Siddharth, correct. Venkatesh, correct. Adi, correct. Yes, Anuradha, that's right. Yes, Giri, that's right. Yes, Pia, that's right. Neeraja, can you check your answer? Naveen, you have to check your answer. Yes, Samna, that's right. Shamila, you have to check. It's partly correct. Raviji, it's partly correct. Ankita, correct. Nishant, correct. Okay, let's see the explanation then. Shall we see the explanation? Okay. So here we are using the midpoint formula. The midpoint formula is the x coordinate of the point is given of the midpoint is given by x1 plus x2 by 2, and the midpoint of the y coordinate of the midpoint is given by y1 plus y2 by 2. So here p is taken as x comma y, and we have the other point q 1 comma minus 3, so it's substituted in the formula, and the midpoint is minus 1 comma 1. So after substituting, we have minus 1 comma 1 is equal to x plus 1 by 2 y plus minus 3 by 2. So equating the x coordinates, x plus 1 by 2 is equal to minus 1. So x plus 1 is equal to minus 2. So you will have x is minus 3. So similarly, if you equate the y coordinates, y plus minus 3 by 2 is equal to 1, y plus minus 3 is equal to 2, y is equal to 2 plus 3, 5. So the coordinates of the point P is minus 3 comma 5. So everybody clear, right? Okay. Shall I go to the next topic? Ravi, you will not be able to speak in your microphone. It's if you want to tell anything, please type it in the chat box. Okay. Sebin, are you able to hear now? Sebin? Okay. So we'll move on to the next topic. Varun, there is no reason. Varun has asked whether the coordinates of the P are taken as x1, y1 for any reason, or it can also be taken as x2, y2. The point can be taken as x2, y2 also, or x1, y1 also. It won't make a difference. Okay. Next we'll see the slope of a line. So the slope of a line is a measurement of the steepness and direction of a non-vertical line. Okay. So here if you see in the graph, there are 2 points, P x1 comma y1 and R x2 comma y2. So what the slope is of the line is actually denoted by change in the y coordinate to change in the x coordinate. Okay. So change in that y coordinate is given by y2 minus y1, and change in the x coordinate is given by x2 minus x1. So we have the slope of the line m is equal to y2 minus y1 by x2 minus x1. You can note down the formula for slope of a line. Ravi, slope of a line is given by y2 minus y1 by x2 minus x1 when the points are given. The coordinates of the points, 2 points are given, x1 comma y1 and x2 comma y2. It is the change in the y coordinate to the change in the x coordinate. Is it okay? Samarjit, we can take any point as x1 and any point as, there is x1 comma y1 can be p or it can also be r. Similarly, if you take r as x1 y1, you can take p as x2 y2. It will give the same answer. For example, if you take r as 2 comma 1, okay, and P as 1 comma 1, sorry, 3 comma 2, then you will have 2 minus 3 by 1 minus 2, which is minus 1 by minus 1, so you will have it as 1. Similarly, if you take the other way round, it is 3 minus 2 by 2 minus 1. So again you will have it as 1 by 1, so it will be the same 1. Okay. Okay. We'll just see the definition of slope here. M is equal to y2 minus y1 by x2 minus x1. For other equation of line, it will be coming henceforth in the other slides. Okay. Yes, the slope denotes the slope of the line PR. Anuradha. Shall we move on to the next topic? Okay. So let's see parallel and perpendicular lines and the relationships of their slopes. Okay. Samarjit, if the slope will not be, if even if it is negative, it doesn't matter which point you take it as x1 y1 and which point you take it as x2 y2. Adi, slope denote it's the change in y coordinate to the change in x coordinate. Any other doubts? Yes, Ravi. Okay. Shall I move to the next topic? This one must derive now. Amna, this formula is used only when two coordinates are given, that is P comma Q. The coordinates of 2 points are given. Then if you have to find the slope of that line segment joining those two lines, then that slope is given. Okay. Uh, so we'll move on to the next topic, parallel and perpendicular lines and their slopes. Okay. So if two lines are parallel to each other, then their slopes are equal. So in the diagram on the left hand side, you see two lines and they are parallel to one another. So their steepness and their direction are same. So the change in the y coordinates to the change in the x coordinates would be same. So the slopes of those two lines are equal. Okay. In the other diagram, two lines are perpendicular to each other. Then the product of the slopes of those two lines is equal to -1. the steepness may be same, but the direction of those two lines are perpendicular to one another, so they are different, so it would come as -1. The product of the slopes of those two lines would come as -1. Okay, just note down that if two lines are parallel, then their slopes will be equal, and if two lines are perpendicular to each other, then the product of their slopes would be equal to -1. Have you noted this down? Hello? You're able to hear properly? Okay. Have you noted this down? Shall I move on to the next topic? Okay. Now let's see the equation of a straight line. Okay. So here we are going to see various forms of representing the equation of a straight line. Okay. So here for this line we have slope m and there is a constant c. So this is the general equation of a straight line. Y is equal to mx plus c, and ax plus by is equal to c is another form of representing the equation of a line, like 2x plus 3y is equal to 5, 3x plus 4y is equal to -2. These are all equations of lines. Here it's like y is equal to x by 2 plus 3, y is equal to 4x plus 3. These are another way of representing straight line. Here we have to understand two things, that is x-intercept of a line and y-intercept of a line. So when consider this line in this right side diagram, here the line intersects the y-axis at this point. Here if it makes b units from this origin, then this will be the y-intercept of the line. It is the y coordinate of the point because it makes 0 units on the x-axis. So the y coordinate of that point will be the y-intercept of this line. Similarly for x-intercept, when the line intersects with the x-axis, it makes say a unit on the x-axis, then that would be the x-intercept of the line. Y on the y-axis it makes 0 units. So this point would be a comma 0, this point would be 0 comma b, and b would be the y-intercept of the line and a would be the x-intercept of the line. Clear? Clear what is how to find x-intercepts and y-intercepts of your line? Rhythm Pandey, actually a and b are constants in that equation. Ax plus by is equal to c. We have like 2x plus 3y is equal to 5, right? So 2, 3, those are constants. It can also be 4, 6, like that. So they are actually constants. You need not confuse with what I said here for x-intercept and y-intercept. This is totally different. I just took a variable. You can also keep it as c and d, x and y-intercepts. Here these a and b are different. They are constants. They are coefficients of x and y. Okay. Neeraja, the sign matters for what? For which one you are asking? Venkatesh, hope you are also clear now. The a and b are not the same which has been given in the general form of the equation ax plus by is equal to c. C is also a constant, a and b are also constants. I gave example like 2x plus 3y is equal to 5, right? So 2 and 3 stand for a and b and 5 stands for c. It's just a constant. Shall I explain once again? I think some of you are still having doubts for x and y intercepts. Okay. Consider this line in the right hand side of the page. Okay. So the line intersects the x-axis as well as the y-axis. Okay, the point where the line intersects with the x-axis, say 4 units from the origin along the x-axis, then the x-intercept of this line would be 4 and the point is denoted by 4 comma 0. Okay, so if the line intersects the y, now consider the other place where it is intersecting the y-axis. So if it intersects the y-axis at 3 units from the origin, then that point is denoted by 0 comma 3 because it makes 0 units on the x-axis. So the point is 0 comma 3 and the y-intercept of the line is 3. Is that clear? Rhythm Pandey, actually the C stands for the y-intercept in the second equation, y is equal to mx plus c. That we will be seeing in the next slides. Supradeep, the y-intercept is actually 0 comma y. The x-intercept is x comma 0. Venkat, we will be seeing the slope of the other lines in the further slides. Yes, Pandey, in the second equation, C stands for the y-intercept only. Okay, I think I'll move on with the next slide. Okay. So here we have various forms of representing the equation of a straight line. First one is the slope intercept form. That is, if the slope of a line is given, that is m, and the y-intercept of the line is given, say c, then the equation can be written as y is equal to mx plus c. Next is point slope form. Here one point is given with the x coordinate and the y coordinate x1 comma y1 and the slope m is given. Then the equation can be derived as y minus y1 equal to m into x minus x1. Okay. Next, in 2-point form, 2 points are given on the line. 2 points on the line, those coordinates are given x1 y1 and x2 y2. Then the equation of that line can be found out as y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. In the intercept form, if the line intersects x-axis at A and y-axis at B, then A is the x-intercept, B is the y-intercept, and the equation is given as x by A plus y by B is equal to 1. Okay. Please note down the formulas or note down the various forms of equations. Slope intercept form, point slope form where point is given and the slope is given. Slope intercept form where slope is given and the y-intercept is given. 2-point form where 2 points are given x1 y1 x2 y2. Intercept form where x-intercept A, y-intercept B is given. Hi Tamal, you've asked whether y-intercept and c is same. See, actually there are various equations. So we have to remember in which equation the variable denotes what. We should not get confused with the variables in two different equations. Okay, that's just for a note. In y is equal to mx plus c is same as the y-intercept. Okay. Raviji, you want to know about points loop form. See, there are 2 points given. Okay. There are 2 points given, x1, y1 and x2, comma y2. Okay. Then y minus the point y1, y coordinate of a point y1 by y coordinate of another point y2 minus y1 is equal to x minus x1 coordinate of one of the points by x2 minus x1. Is that clear? Okay, then we'll move on to the questions. Oh, yeah, Raviji. Actually, point slope form, then one slope of the line is given, that is denoted by m. Okay, and another point is given, x1 comma y1. That point lies on the line. Okay, so then you can derive the formula as y minus y1 coordinate of the point, y coordinate of the point equal to slope of that line into x minus x1, that is x coordinate of that point. Clear? We will be seeing some questions in the next slide. That would be your examples for these equations. Okay, so let's move on with the next slide. Okay. Raviji, in the point slope form, m will be given in the question. The slope is given. Okay. See, here what is given is, if the slope is given and a point is given, then how to derive a equation? That is what is asked. So slope will be given. Okay. I'll move on with the next slide. And let's see the first question here. Find the equation of the line that has a slope of 5 and a y-intercept of 2. Okay. So here what is given in the question is that slope m is equal to 5 and the y-intercept is equal to 2. So here we have to take the y-intercept as c actually. Okay. The slope we have to take m is equal to 5. Now we have to find the equation of that line. So what form of equation we have to use here is correct. I can see that many of you have given the right answers. It is the slope intercept form, and yes, the answer is y is equal to 5x plus 2. Okay, so let us see the explanation of that question. I think many of you have got it right, so not much of an explanation here. Y is equal to mx plus c, m is equal to 5, c is equal to 2, so y is equal to 5x plus 2. Very good. Let's move on with the next question. Okay, so the next question asks, find the equation of the straight line that has slope m is equal to 4 and passes through the point minus 1 comma minus 6. So what is given in the question is slope m is 4, point on the line is minus 1 comma minus 6. So we have to find the equation of the line. Many of you have got the right answers. So we have to use the point slope form here. Okay, so let's see the explanation for it. X1 is -1, Y1 is -6. For point slope form, it is Y minus Y1 equal to Y2 minus Y1 by X2 minus X1 into X minus X1. So we can find the slope of the formula by Y2 minus Y1 by X2 minus X1. That would be 4, and we have X1 as -1, Y1 as -6. So y minus -6 is equal to 4 into x minus -1. So that will be y plus 6 is equal to 4 into x plus 1. So y plus 6 is equal to 4x plus 4. So we have the equation of the line as y equal to 4x minus 2. So I think many of you have got the right answers, so you're clear with that. So this is of that, this represents that equation of a line form y is equal to mx plus c. Okay, so this is represented in that form, y is equal to 4x minus 2. Okay, let's see the next question. Given that the line passes through the points -2, 4 and 1, 2, find the equation of the line. So here 2 points are given, -2, 4, 1, 2, and we have to find the equation of the line. So we have to use the formula for finding the equation of the line with coordinates of 2 points. Okay. So let's see the explanation. So here the equation of the line is given as y minus y1 equal to y2 minus y1 by x2 minus x1 into x minus x1. So the points are substituted and you will get the answer as y is equal to -2 by 3x plus 8 by 3. It can also be written as 2x plus 3y minus 8 equal to 0. So many of you have got the right answers. Good. Shall we move on to the next question then? Find the x and y intercepts of the equation given below. 2x minus y is equal to 2. Okay. So what is given is the equation of a line. What we have to find is the intercepts, x-intercept and the y-intercept of the line. Okay. So we know that with x-intercept and y-intercept, the equation of the line that can be used is x by a plus y by b equal to 1. Okay, let's see the explanation. So many of you have got the right answers, 1, -2. So the equation of a line in the intercept form is x by a plus y by b equal to 1. The given equation is 2x minus y equal to 2. So we have to convert this equation to this form, x by a plus y by b equal to 1. So what we can do is we have to divide the equation by 2. So when you do that, you can represent it as x by 1 plus y by -2 equal to 1. So we have a equal to 1, b equal to -2. So that is your x-intercept and the y-intercept. Okay. So many of you have got it correct also. That's good. So let's move on to the next topic, parabola. Okay. So the straight line is represented as a linear equation. Y is equal to mx plus c. Okay. The degree of x is 1 there. Now when the degree of x becomes 2, that is, it is a quadratic equation. Y is equal to ax square plus bx plus c. Then it becomes a parabola. Okay. So that is why it's mentioned here. If a is not equal to 0, then graph of the equation will be parabola. Because if a becomes 0, then the equation becomes y is equal to bx plus c, which is nothing but a equation of a straight line. Okay. So while you see this equation, y is equal to ax square plus bx plus c, then we can say that it will surely be a parabola. Now there are two types of parabola, one which opens upward and the other one which opens downward. So if a is greater than 0, that is you have y is equal to 2x square plus bx plus c. A is greater than 0, then the parabola will open upwards. If a is less than 0, that is y is equal to say minus x square plus bx plus c. Minus 1 will be the coefficient of x square, and that is less than 0, then the parabola will open downward. Okay, so now let's see some graphs in parabola for this. Okay, before that, we can see what a vertex of a parabola is. Now the vertex of the parabola is the high point or the low point of the graph. Okay, here see, it is the low point and this is the high point in this parabola, whereas in this parabola this is the low point, and this is known as the vertex of the parabola. Now there is a formula to find the x coordinate of the vertex. Remember the x coordinate of the vertex. So we know the equation of the parabola is y is equal to ax square plus bx plus c. In that a and b are constants. They are coefficients of x square and x. So the coefficient of x square a comes in the denominator to find the coordinate of the vertex, which is given by minus b by 2a. Okay. So now how to find the y coordinate of the vertex? We have found the x coordinate of the vertex. Now how to find the y coordinate of the vertex? We have to just substitute it in the quadratic equation. Y is equal to ax square plus bx plus c. So here if you substitute the x coordinate of the vertex for x, then you will get the value of y, and that would be the y coordinate of the vertex. Okay. Next we shall see what happens in case a is greater than 0. Okay, so let's take the equation y is equal to x minus 1 the whole square plus 1. Now if you expand it, you will get y is equal to x square minus 2x plus 2. So here a, the coefficient of x square, is greater than 0. So we can infer that the parabola will open upwards. Okay. Now let's see the graph for that. Before that, let's see a small explanation here for that. Y is equal to ax square plus bx plus c. So y is equal to x square minus 2x plus 2. So we have the coefficient of x square a is equal to 1, coefficient of b is equal to minus 2, and the constant c is equal to 2. So the vertex is minus b by 2a. That is minus of minus 2 by 2 into 1 equal to 1. So to find the y coordinate, you have to substitute 1 in the function for x, in the equation for x. So y is equal to 1 minus 2 plus 2, that would be 1. So hence the vertex is 1 comma 1. We know that domain of a function f of x is all the values that x can take. So here if you see, x can take all the real values, and range is the values that the output f of x, or here in this case y, can take. If you substitute the value of x is equal to 1, that is the minimum point x can have. So y is greater than or equal to 1. With that you can draw the graph of the, we can plot the parabola for this equation. Okay. So when x was 0, y was 2. When x was 1, y was arrived as 1. So when x is 2, y is arrived as 2. So this is the low point, and you are getting the range of y as greater than or equal to 1. And for x, it is all real values. Okay. Raman, in the next slide, we'll see what happens when the coefficient is less than 0. Okay. I hope your question will be answered then. Shall I explain again how to draw a parabola, or everyone is clear? Do I need to explain again how to draw the parabola? Okay, I'll make it little fast this time. Take the equation y is equal to ax square plus bx plus c. Okay, so in this case the equation is y is equal to x square minus 2x plus 2. So here we have a is equal to 1, b is equal to minus 2 and c is equal to 2. Okay, so first we have to find the vertex of the parabola. So x coordinate of the vertex is given by minus b by 2a. b is minus 2, a is 1. Substituting, we will have x as 1. So substituting x for 1 in this equation, y is equal to x square minus 2x plus 2, we will have the value of y as 1. So 1 comma 1 is the vertex. So we know where to draw the vertex, 1 comma 1. Now if you see this equation, y is equal to x square minus 2x plus 2, x can take all real values. So that is the domain of x, that is it can take all real values. Okay, so we have just taken for example 0, 1 and 2. Okay, next when you substitute 0 in the equation for x, then we are getting y as 2. When you substitute 1, we are getting y as 1. When you are getting substituting x as 2, you are getting y as 2. So when you plot these points, you can see that the graph goes like this. So it is opening upward. That is what we saw first, that if a is greater than 0, the parabola will be opening upwards. So in your GRE, you don't have to like totally plot the points and get to know. If you see that a is greater than 0, you can directly infer that the parabola will be opening upward. Okay, you can just note that down. If a is greater than 0, then the parabola will be opening upward. Yes, Suvrati. Vertex is the low point for the parabola. It can be the low point or it can also be the high point. For upward parabola, it will be the low point. And for downward parabola, it would be the high point. Okay. Okay, let's see another parabola also now. That is, let us take the equation y is equal to 2 minus x square. So now the coefficient of x square a is minus 1, which is less than 0. So now the parabola is going to open downward. So again here, if you substitute values for x like 0, 1 and 2, you can get the values of y. And if you plot, if you will get the parabola will be downward facing. So here y is equal to 2 minus x square, a is minus 1, we don't have bx, so b is 0 and c is 2. So then you will get the x coordinate of the vertex as minus b by 2a, so that would be 0. Y is equal to 2 minus 0, that is 2. So you will get the vertex. For x is equal to 0, you have y is equal to 2, so vertex is 0 comma 2. Now take a value for x, one value below 0 and another value above 0. So when you take like that, you will have like x as minus 1, substituting 2 minus minus 1 the whole square, 2 minus 1, 1. So y will have 1. Substituting x is equal to 1, a value above 0, you will have 2 minus 1, again 1. Okay, so that would be the downward parabola. So in GRE, if you get an equation where for the parabola a is less than 0, then you can assume that it is a downward facing parabola. Yes, Shamila, if a is 1, it is greater than 0, so it would be upward, facing upward. Tamal, vertex is the low point or the high point of a parabola? Varun, see, x is actually 0. Okay, for the vertex x is 0. So the values of y, if you substitute one value of x, one point above 0, that is 1, and another point below 0, minus 1, like this, you see that y is taking all the values which are less than or equal to 2. So that is why the range is less than or equal to 2. That is the value of all the output, all the values that the output y or f of x can take. Hope you are clear now. Yes, Shamila, I can write the equation also as x square minus y plus 2 is equal to 0. Sorry, x square plus y minus 2 is equal to 0. Okay, let's move on to the next slide. This is quite interesting and also important. Okay, here it is not necessary to understand how these things are derived. What you have to learn is how you can infer the graph when a constant is added to the x-axis or a constant is added to the y-axis, that is f of x. Okay, so in the first graph, what happens is we are adding a constant c to f of x. Now the blue line, blue graph denotes the parabola f of x is equal to x square. So when a constant c is added to f of x, then what happens is the parabola gets shifted upwards. It gets, like you can remember, it gets added. So it gets shifted by c units. So the vertex, the x coordinate was 0 here. Now it becomes c for the vertex. Okay, so it's getting shifted by c units upwards. Similarly, what happens if the constant is subtracted? Like f of x is x square, this is f of x is equal to x square plus 3. What happens if 3 is subtracted? So f of x is equal to x square is this blue graph. F of x is equal to x square minus c or x square minus 3. Then the graph gets shifted downwards by c units. That is, if it is 3, then it gets shifted down by 3 units. The vertex x coordinate of this vertex was 0. Now for this it would be minus 3. Okay, y coordinate remains the same. Sorry, x coordinate remains the same, y coordinates gets subtracted by 3 units. Okay, so next see the third graph. Here what happens is constant is added to x instead of f of x. So f of x is equal to x plus c the whole square. So now what happens is this, it is added to the x-axis, right? So the graph gets shifted along the x-axis. But if you add to x, the graph gets shifted along the left hand side. Okay, it gets x along x-axis, it gets shifted from 0 to minus c. Okay, so if a constant is added to x, the vertex and the graph gets shifted by c units along the left hand side. Now instead of adding a constant to x, if it is subtracted from x, f of x is equal to x minus c the whole square, the graph gets shifted along the x-axis, but now it gets added. It is vice versa. Okay, so if a constant is added to x, it shifts along the left hand side to minus c. When it is added, when it is subtracted, x minus c whole square, it gets shifted along the right hand side. Okay, now the last two graphs, what happens is you are multiplying the equation x square. That is, you are giving a coefficient to x square. So this is f of x is equal to x square. If you get f of x is equal to c into x square, you have to concentrate on what is the value of c. If it is in between 0 and 1, then the graph expands. If the constant is greater than 1, then the graph shrinks. Okay, so I'll just repeat it quickly once more. F of x is equal to x square. when C units is added to f of x or y, then the graph gets shifted upwards by C units. F of x is equal to x square. When C units is subtracted from f of x, then the graph gets shifted downwards. F of x is equal to x square, where C units is added to x, it becomes f of x is equal to x plus c whole square. It gets shifted along the x-axis on the left hand side. F of x is equal to x square. C units is subtracted from x, then it gets shifted along the right hand side. This is f of x is equal to x square. You are giving a coefficient of 2x square. C, it can be in between 0 to 1 or it can be greater than 1. If it is in between 0 to 1, then it expands, and if it is greater than 1, then it shrinks. Shamla, it's not like you have to remember all this, but it would be helpful if they ask like how the graph will look. They may ask questions like that. So at that time, this would be easier. You can finish your, identify the graphs easier. Otherwise, you have to give values for x, then find values for y. It would take some time. This is like a shortcut for that. It is quite easy. If you go through it like two or three times, you will find it very easy. Okay, so we shall move on to the next topic then. Garima, the proofs would be very long. Okay, you just understand how the graph is changing when the constants are added. That would be enough for you. Okay, so let's move on with equation of a circle then. This is quite easy. We have Supradeep, if you want to know about the proofs, please contact us later or just post a doubt in the learning tracker. Then we can resolve it. Okay, it is quite lengthy. It's not needed right now. Okay, and let's see the equation of a circle. So the standard form for the equation of a circle is x minus a the whole square plus y minus b the whole square is equal to r square. So here a comma b is actually the coordinates of the center. A is the x coordinate of the center, b is the y coordinate of the center, and radius is denoted by r. So it is quite simple. X minus a the whole square plus y minus b the whole square is equal to r square. So now let us just see an example or a question based on that. So here you have to find the equation of the circle. So what is given from the diagram, what can you infer from the diagram is you have the center C, the x coordinate is 1, the y coordinate is 0. So your center has the coordinates 1, 0. Now we have to find radius. So radius is the distance between the center and endpoint of a circle. We can find it is center, one endpoint is the origin, so 0 minus 1, that would be your radius 1 unit. You can find it that way, or you have the other endpoint 2 minus 1, 1, so your radius is 1. So hope you have all found the equation of the circle. It is x minus 1 the whole square plus y minus 0 the whole square equal to 1 square. X minus 1 whole square plus y square is equal to 1. Yes, Shrikant, you're right. Equation is correct. Okay. Now let us go to the next topic then. Shall we move on? Everyone clear with the equation of circle? Okay, good. Let's move on to the next topic. That is, we are going to see some examples for plotting graphs. Okay. So let us see f of x is equal to square root of x minus 2. Now what are the values that x can take here? X can actually take in general any real numbers, but here f of x square root is asked. When for square root, it cannot take negative values. Square root of a negative number will be an imaginary number. So we are only dealing with positive values. So x is all positive real numbers. So the domain for x is greater than or equal to 0. So substituting for x is equal to 0, we have to find what is the value of f of x. You are getting it as square root of 0 minus 2. So 0 minus 2, that is equal to minus 2. Now substitute x is equal to 1. Then you will get f of x is equal to square root of 1 minus 2. That is 1 minus 2 equal to minus 1. Then substitute x as 2. F of x is minus 0.6. So similarly for 3 and 4, you will get minus 0.3 and 0. So when you plot it like that, plot these points, okay, you get the graph as shown below. Yes, Shamila, we can take y is equal to f of x. If in the equation it is given like y is equal to square root of x minus 2, then we can consider it as y. If it is given as f of x, then you have to consider it as f of x. Both of them would mean the same. This can also be given like function f of y is equal to square root of y minus 2. It would be a function in variable y. Varun, see, x can have the minimum value 0. When x has the minimum value 0, when you plot the graph also, what you can see is f of x is having the value minus 2. And when the value of x goes on increasing, the value of f of x is also keeps on increasing. And it is always, as shown in the graph, it is always greater than minus 2. So the range of function f of x is greater than or equal to minus 2. Hope you're clear now. Shamila, f of x you have to plot it along y-axis only. It's like x is the input, f of x is the output. So y-axis is denoting the output of the function and x-axis is denoting the input of the function. Varun, range is like all the values that the function f of x can take. Okay, good. So we'll move on to the next example. Okay, see, it's very similar to the before example. F of x is equal to square root of x minus 2, and this is f of x is equal to square root of x minus 3. Okay, here again, see, when square root is function is taken, square root will always take only positive values, because square root of negative values is an imaginary number. So here x minus 3 should be greater than or equal to 0. Okay, so when you give x minus 3 is greater than or equal to 0, you will get x is greater than or equal to 3. So the domain of x is greater than or equal to 3, that is the domain for domain of the function. Okay, so now we have to find the range of the function f of x. Okay, so here if you substitute 3 for x, you get f of x as 0. Then substitute higher value for x, say 4, then you will get f of x as 1. Then substitute 7, 12 like that, and you will get values like 0, 1, 2, 3, etc. Okay, so you will get the graph as shown in the figure. So f of x is all increasing along with x, and f of x is greater than or equal to 3. So the range is greater than or equal to 3 for f of x. Okay, you're clear with that? Chetan, there is no particular thing like we have to take only these values. We have just taken that for an example, 3, 4, 7, 12. If you want, you can also take 5, 6, substitute and see how the value is coming. If you plot the graph again, you'll have it in the same way only, same trend only. Shrikant, you are asking why there is a square bracket given and a angular bracket given for the interval. When you say square bracket, it means closed. That is the starting point. It doesn't go beyond that. But when it is given as open bracket, it means uh, that it just keeps on going. It's not closed. It's open. If you say like square bracket 0, it means it also includes 0 and the points from that. When it is given like angular bracket, it doesn't have an end point. It doesn't include that particular point. Hope that's clear. So Pradip, this is half open interval only. This half open on the right hand side. There is infinity, it is open. Starting point is closed. Chetan, I think there is difference in the previous problem and this. F of x was square root of x there. Here it is f of x is square root of x minus 3. No, Ankita. See, here what happens in the f of x is equal to square root of x is f of x is equal to square root of x is, we know that square root function doesn't take any negative value, right? So here whatever is given in this argument for this function square root x, so that should be greater than 0. So we took values from 0 for x. But in the next question, we have like argument for square root function as x minus 3. So x minus 3 should be greater than or equal to 0. So that gives you a condition that x is greater than or equal to 3. So that is why we have taken from 3 and not from 0. Hope the difference is understood. Yes, Ankita, lowest value of x in this case would be 3. Had it been square root of x minus 5, then lowest value of x would be 5. Okay, so shall we see some questions? Ankita, actually, see, f of x is along the y-axis, right? So x is only taking values from 3, whereas y-axis f of x is taking values from 0 to 3. So that is why it's given from 0 to infinity. Yes, Nikhil, you're right. Domain is all the values x can take. You can derive that from x minus 3 greater than or equal to 0. So x is greater than or equal to 3. Okay, so let's move on to the next questions. Okay, so we have got two functions here. F of x is equal to 3x plus 2 and g of x is equal to 2x minus 1. Now you have to find the number of points of intersection given. You have to find what are the points of intersection and how many points of intersections are available for these two functions. You have to remember that for points of, what is a point of intersection? If you imagine when two equations are there, here the lines, that is the equations represent two lines, right? Two straight lines. So the two straight lines would cross one another at some point. So that would be the point of intersection. So if you imagine that at that point, the x coordinate and the y coordinate would be same for the point in both the equations. So you're able to solve the problem you are able to imagine or have any idea how to approach it? Anyone? Anyone has started with the problem? Shall we move on with the explanation then? Yes, Neeraja, you're right. Okay. We'll see how we have to find the point of intersection. Okay. See, I think some of you have also got correct answers. That's good. See, what happens is the point of intersection remains the same. I mean, the x coordinate and y coordinate remains the same at the point of intersection in both the graphs, right? So, f of x actually denotes the y coordinate of the point in the first equation, and the g of x represents the y coordinate in the second equation. See, it's like this. This is f of x, this is g of x. So at this point, f of x also has the same value, g of x has the same value. And x in both the equations also has the same value. So if you equate both the y coordinates, 3x plus 2 is equal to 2x minus 1, you can solve and get x is equal to minus 3. So you have the x coordinate for the point of intersection. Then to find the y coordinate, you have to substitute that in one of the equations. In any of the equations, you will get it as minus 7 only in this case. Okay, so f of x is 3x plus 2, put x as minus 3, you will get f of x is equal to 3 into minus 3 plus 2, that is minus 9 plus 2 is equal to minus 7. Narendra, as I said, the y coordinate would be same in both the equations at the point of intersection. So, we are y coordinate in the first graph is given by 3x plus 2, and in the second graph it is given by 2x minus 1. So we are equating both of these and we are getting the answer. Amna, actually, like as long as the lines aren't parallel, they will meet at any point. Okay. See, if the equations were given like f of x is equal to 3x plus 2 and g of x is equal to 6x plus 4. Okay. Then if you equate it, you will not get any solution because they are parallel lines. That you can see probably from the slope of the lines. See here f of x is 3x plus 2, g of x is 2x minus 1. So the slope of the lines are different. So they are two different lines. They are not parallel lines. Okay. Okay. Let's shall we move on to the last question for today? Okay. Yes, Suvradip, for any two lines you can solve it in this way. Even if they are perpendicular, then you can equate their functions. Nikhil, mostly we determine the lines are perpendicular to one another only from their slopes. Find the slope of the two lines, multiply them, find out whether they equate to minus 1. If they do, then they are perpendicular. Raman, in your case, it is not a straight line because you're saying greater than or equal to. That is like an inequality. It should be an equation for a straight line. While you are saying y is greater than or equal to 3x plus 2, you are considering a set of lines, not a particular straight line. Okay, let's see the next question. So here f of x is given as x square minus 8x plus 20 and g of x is given as minus x square plus 4x plus 2. Now we have to tell me how many number of points of intersection are there. Yes, Vijay, you are right. Yes, Shamila, you are also correct. So here actually there are two functions given. The two quadratic equations, so they are going to be two parabola. So while you're to find the point of intersection, you can approach in the same manner. You can equate the both of the functions f of x and g of x to find the points of intersection. Okay. Bharat, check your answer. Suvrati, please check your answer. Amna, Sebin, you've got it wrong. Others all have got it correct. You can also find the coordinates of the x and y of the point of intersection. Okay, let's see the explanation. See, f of x is given as x square minus 8x plus 20. G of x is given as minus x square plus 4x plus 2. So to find the point of intersection, we have to equate these both. So you will get x square minus 8x plus 20 is equal to minus x square plus 4x plus 2. So you will have like 2x square. Okay. Okay, then you will get it as 2x square minus 12x plus 18 equal to 0. So we know that for a quadratic equation, the roots are found out as minus b plus or minus root over b square minus 4ac by 2a. So here a is 2, b is minus 12, c is 18. So you will get x is equal to minus of minus 12 plus or minus root over minus 12 the whole square minus 4 into 2 into 18 by 4. So you will get that x is taking only one value 3. So the number of points of intersection is 1. Generally in parabola there can be like 2 points of intersection, but in this case there is only 1 point of intersection because they are touching one another like this. They are touching, the parabolas are touching one another at this point 3 comma 5. So you got the point x is equal to 3 here. Substitute in one of the equations. In both the equations you're going to get the same value because the y coordinate for the point of intersection will be the same in both the equations. So the answer is 3 comma 5. That's clear. I think many of you have got the right answers. Okay, 7. See, you have got f of x and g of x, right? So you have to equate both of them. So you'll get like f of x is equal to g of x. When you equate them, you're getting x is equal to 3. So you're getting the x coordinate of the point of intersection. Now substitute that in f of x or g of x. You'll get value 5. So 3 comma 5 becomes your point of intersection and there is only one point of intersection. That's clear? Janavi, it just depends on the question. If it asks for number of points of intersection, then you can give it as 1. If it tries to find the point of intersection, then you can find it as 3 comma 5. Okay guys, I think we'll wind up the webinar with this today. Hope you all found it interesting and you also understood.
Yes, thank you guys. Soon we will upload the recordings and slides of this webinar in our website. You can download it, and if you have further queries, you can send it to support@greh.com. Your SFA concern will explain you in detail. Thank you so much for attending this webinar. All the very best for your preparation and all the very best for your GRE. And if you have further questions, please send it to support@greh.com. Your SFA concern will give you the solution. Don't worry, guys.